As we begin to consider the integrals of trig identities, one thing to keep in mind is that all of your trig identities, like sine squared plus cosine squared equals 1, still apply. And when we're integrating trig identities, we're really just reversing the derivative process. So it's important that you have straight the relationship between the different trig identities in both directions, so to speak. So here we have the integral of 4 sine x dx, and I know that sine x, when I take a derivative, comes from cosine x. And so when I integrate a sine function, I'm going to get a cosine function. Specifically, it'll be 4 cosine x. But the odd thing is that the derivative of cosine is negative sine, so this must have started off as negative. So the integral ends up being equal to negative 4 cosine x plus c. And you might consider referencing that chart that's on the middle of your notes as well. Let's consider the next problem, the integral of negative 2 cosine x over 3. I just think about this as negative 2/3 cosine x dx. And so here, the derivative of cosine is simply sine. So this would have been negative 2/3 sine x plus c. Next problem we have is the integral of 5 over cosine squared x dx. Well, I don't know anything about cosine squared x, but I do know that 1 over cosine squared x is the same as secant squared x. So at this point, I need to see in this, oh, this is the same as 5 secant squared x dx. And I know that secant squared is the derivative of tangent, so the integral of this would be 5 tangent x dx. Now there are some other options that we have. We just haven't gone over other options. But again, trig identities still apply. Don't need the dx because I took the integral, and I must remember the plus c. Our fourth example with our trig identities, and again, I would recommend trying them yourself before I do them. It's the integral of 4 cosine x minus 9 sine x dx. The integral of cosine is sine, so this must have been 4 sine x originally. The integral of negative sine is cosine, so this must have been plus 9 cosine x plus c. Our next example, dealing with the trig. What is the integral of negative sine x over cosine squared x dx? Well, I don't know anything about these specifically, nor do I know it about a quotient form, but I do know that sine over cosine is tangent. So sine over cosine, since it's tangent, this must have been something like negative tangent x. And I know 1 over cosine x is secant x. So I can rewrite this as negative tangent x secant x dx. And I know that that is the derivative of secant x, which is related to it. So the integral of this would be negative secant x plus c. Finally, I'm being asked to integrate theta squared minus 2 cosecant, let me just write that neater, cosecant squared theta. And instead of with respect to x, we're integrating with respect to theta, so theta is my variable. theta squared is really no different than x squared, so this integral of theta squared is 1/3 theta cubed. The integral of cosecant squared is negative cotangent, so this must have been plus 2 cotangent theta plus c. Now we've got some examples on integrating basic trig functions.